Okay, here we go. Kinesiology 230, chapter 17, still talking speed development. This is a bit of a work and power revisit, a lot like we talked about in the previous presentation. Let's be a little bit more in depth in terms of our revisit, and we're going to talk about acceleration in speed development. All right, we talked about this before with work. Work is the application of force over a distance. If I say push that boulder for 10 meters, is it smooth? Is it round? Or what surface are you pushing it on? Does it roll? Or is there a friction coefficient where you're pushing it along the floor and it's sliding? But if I ask you to push it as fast as possible, then it becomes a component of time. And then that component of time now makes it power oriented as opposed to work oriented. And that's one of the fundamental differences between like a deadlift, where you can lift that weight and it takes you half an hour, you can do it. Whereas power clean, because of the technical proficiency and some of the technical components required to hoist the weight, there's time involved, and that there's a time component involved, which means you're actually incorporating more power into this side versus this side. Now, if I ask you to go ahead and push a heavier boulder, more work. If I ask you to push it for a further distance, more work. Push it up a hill, more work. Push it faster, more power. And that's the fundamental difference about time. And we talk about acceleration. I mean, acceleration itself is gravity. It's 32 feet per second squared, 9.8 meters per second squared. But it's a measure of acceleration. When we're talking about sprinting, and we talk about sprinting in terms of going from 0 to maximal, that's acceleration. Now, maximal speed is something different, and I'll talk a little bit about these differences here in a moment. It's analogous to like going from 0 to 60 when you're in your car versus, and you can juxtaposition that with like going on a 40-yard dash. 40-yard dash is more of a measure of acceleration, where 100 meters is, sure, the first 40 yards or first 40 meters is about acceleration, maybe even 30 meters. And then you have the transition phase where you're running upright. And then you get to like the last 20 to 30 meters, and it's all about just holding on for dear life. You try to generate as much speed as possible and not give it up towards the last 30 meters of a race. But what we're talking about with acceleration is how quickly you can go from 0 to maximal speed. And if we look at this in terms of timing, and we have this kind of in our head, we want to run a 40-yard dash. We're going to run a 40-yard dash, and our maximal speed is seen denoted by these dots, and it's here, here, and here. A 40-yard dash at a 4:05 time equates to about, now give or take, I mean, it depends which site you go to, but when you calculate it out, it comes out to about 21.5 miles per hour. And it depends. A person might be a little bit faster on the front end. They might build speed on the back end, but just for sake of comparison, 4.5 40-yard dash is 21.5 miles an hour. Okay. What you have is, if you think of different sports and you think of different body types, you may have a running back who gets to maximal speed in a much shorter amount of time. Perhaps your linebackers might take longer to get to 4.5. You might have a defensive lineman that takes even longer to get to 4.5. Or you might have an offensive lineman or a defensive lineman, a big body dude who never gets to 4.5. They run the 40-yard dash in 5 seconds flat. My point is, the measure of acceleration is how quickly we get to maximal speed. And in this example, because time is on the bottom here, the x-axis, this person took longer than this person in the yellow. And so the person here that's in the yellow was able to reach that 4.5 much faster. They reached that top end maximal speed at 21.5 miles an hour in a much shorter amount of time. They had greater acceleration, whereas the person in blue, it took them longer to get to 21.5 miles an hour. They have lower acceleration. That's about the best way I can frame it up for you. Acceleration is just its rate of change, when it's all said and done, of speed over time. And I'll just say this and kind of preference this by saying, people often talk about speed kills in athletics, and really that's not the case. No, it's actually more about acceleration. It's how fast you can get from 0 to maximal speed. And it can happen in any number of different vectors. It can happen straight ahead. It can happen laterally. It can happen vertically, right? So pick your 3 cardinal planes. But acceleration is what kills in sports. It's not top end speed. It really isn't. Now, when you get into running and running for distance, and yeah, speed's your winner there. But in most athletic events, whether it's running cross court or a tennis ball for a cross-court shot, jumping for a basketball, or sprinting to catch a ball in the outfield, it's acceleration, 100%. And just kind of wrap yourself around the different vectors. Going forward, sagittal plane, going vertical, frontal plane. Could be a little sagittal plane there too. And this is more frontal plane as he's jumping to the side to get to that ball. So it's any number of different planes of movement. It could be multiplanular also. Now, if we talk about the human body, and this is something you guys should be well informed on by this point, we have bones, which are the levers, the central nervous system is the wiring, the organs are kind of the operational system, and then the muscles, that's what makes the movement happen. And we talk about potential versus kinetic energy. With potential energy, the stretched rubber band has potential energy. When you let go of that, it has kinetic energy. And so if we look at this in terms of slow-mo here, let it play. Potential, kinetic. When we talk about sport-specific training, whether it's plyometrics like we talked about earlier in this chapter, or we're talking about sprinting, our bodies are going through potential to kinetic, potential to kinetic, potential to kinetic over and over and over again, many times a second in different areas of the body. And it's a constant cycle of potential to kinetic. And I can't stress this enough, in terms of like the entire operational system of the body working as one unit. It actually is a bunch of subunits all working together to make that magic happen. But specific to running and sprinting, it's the muscles being able to go from potential to kinetic over and over again that allows that to happen. So whether it's contracting to apply force into a medicine ball, you're applying force into the ground to jump, or you're doing something to apply force into the bar to do a power clean. The concept is potential to kinetic over and over and over again, and you have to think of it in those terms. And now let's go ahead and think back to like our running technique drills. And the running technique drills, you're doing very low-level plyometric drills and teaching a very specific skill that is sprint technique. And you're teaching the body how to go from potential to kinetic in a very low-grade fashion and incrementally increasing that as you go through the different drills and ABC drills. And then you have a sprinter who's actively applying all those skills into a game or competition environment. That's what you're after when you start talking about speed development and working with athletes. Potential to kinetic and how to apply it to the game environment. Moving on.